Ibon, my dear children, today I am going to teach you a very important lesson, that is probability. You will have 10 or more than that marks for that lesson for the O-level exam. But sometimes this question comes with the sets lesson and sometimes it's come alone. So, however, I am going to teach you the lesson probability from the beginning. So first of all, let us learn what is sample space of probability. The set of all possible outcomes is known as the sample space. That means when you toss a coin, you will have head or tail for the answer. Either when you toss a die, you will have 1, 2, 3, 4, 5 or 6 as the answers. So those are known as the sample space when we consider about probability. Events. An event is a subset of the sample space. As we previously discussed, when we toss a coin, if we need the answer as the head, that is an event. Simple event. Simple event means an event consisting of only one outcome is called a simple event. That means when we toss a coin, if we have head, there is only one outcome. If we have the answer as tail, there is only one outcome. So that is a simple event. For another example, getting 5 when tossing a die, you will have one answer, that is 5. Composite events. Composite events which are not simple are called composite events. That is very simple, but that is a composite event. For an example, getting even numbers when tossing a die, you will have 2, 4, 6 as the answer. Okay, let us learn what is equally likely outcomes. If each of the outcomes in a random experiment has an equally likelihood of occurring, that experiment is called an experiment with equally likely outcomes. You can easily understand that thing by the topic, equally likely outcomes. For an example, getting head when tossing a coin, you will have one answer. Getting tail when tossing a coin, you will have one answer. So the answers are equal. That means the outcome, you will have one answer for each. So the answers are equal. Then when you write a probability of any event, you have to write according to this order. Put an equation mark, then number of elements in the event that you are expecting, then as a fraction of number of elements in the sample space. You have to write according to that order. That means when you write the probability of having head when tossing a coin, you have to write it as 1/2. So you have to keep that in your mind. And there's another thing that you have to remember, that is probability of A union B. Imagine A and B are two events. So A union B is equal, probability of A is added to probability of B and subtracted by the intersection of probability of A intersection B. Keep that in your mind. That is also a very useful equation for your O-level exam. Then let us understand what is mutually exclusive events. If A intersection B, that means, as I told you before, if A and B are two events and the intersection of those two events is a null, if the answer is null, then we could say that A and B are mutually exclusive. For an example, 2 and 4, 1 and 3. As you can see, there is no any intersection for those two sets. So in here we can say that A intersection B is null. So if A and B are mutually exclusive events, we can write the above formula as probability of A union B as equals probability of A is added to probability of B. That is very simple to remember because there is no any intersection, so you can use it from the previous equation. Then the next one, independent events. From the topic you can understand what is an independent event means. Independent event, if one event does not affect another, the two events are called independent. So if probability of A intersection B equals probability of A into probability of B, then we can write A and B are independent. Either we can say, if two events are independent, you have to remember this formula. Probability of A intersection B equals probability of A into probability of B. For an example, getting a side by tossing a coin. The answer does not affect each head or tail. That is a probable answer. When you have the answer as head, it does not affect to the tail. When you have the answer as tail, then it does not affect to the head. The next most important thing is representation of the sample space in a grid. For this thing, I would explain it to you with an example. Imagine a bag contains identical beads. There are 3 red beads and 2 blue beads. A bead is taken out randomly, its color is recorded and then put back in the bag. A bead is taken out from the bag again and its color is recorded. For this thing, you can draw the sample space like this. Drawing 2 axes, and you can name one axis as R1, R2, R3, B1, B2. Using the same thing, you can use R1, R2, R3, B1, B2 for the y-axis and x-axis both. By using the grid, you can write the answers for this one. Find the probability of the following events using the above grid. Both beads being red. So if you look at the grid again, both beads are red means R1, R1, when you go from the both side, it will meet. Then R1, R2, R2, R1. Likewise, if you can identify the correct part, then you will have the answer as 9/25. Next question is, you have to find the probability that both beads being the same color. Again, if you can identify the correct part of the grid which has the same color, then you will have the answer as 13 over 25. Okay, let us move on to the next question. That is the most important part for your O levels, that is tree diagrams. There will be a definite question from tree diagrams part. So for this one also, I will explain it to you again by another example. Imagine that a box contains 4 red pencils and 2 black pencils. A pencil is taken from the box at random and did not return back to the box after its color is recorded. And then another pencil is taken out of the box. That means if we summarize this thing, the first event is there is a box, and in that box there are 4 red pencils and 2 black pencils. If you take one red pencil randomly out, then you will have the second event as now there will be the box, but the thing is, if you have taken out a red pencil, now there will be 3 red pencils and 2 black pencils. That is a one situation. Imagine if you take out one black pencil randomly out, then the second event will be like this. There will be the box, and in that box there will be 4 red pencils. As you have taken out one black pencil, now another one is remaining, that is in the box. Now we can draw the tree diagram like this. For the first event, we can draw a branch like this. In that branch, at the end we can write the result as red. For the another branch, we can write the answer as black. That means when you have taken out the pencils randomly out from the box, you will have the answers as red or black. For the first one, for the red, you will have 4 over 6. That is, for the first time there are 6 pencils and 6 pencils altogether, 4 red pencils from that, and there are 2 black pencils from out of 6 total pencils. For the second event, if you have taken out a red pencil out, then for the branch you can write it again as red and black, because still in that box there are red pencils and black pencils. Even you have taken out a red pencil. For the red pencil, now there will be a reduction of 1, so now there will be 3 pencils only. Now the total will be changed as 5, so we can write it as 3 over 5. For the black pencils, it does not change, so we can write it as 2 over 5. Imagine now if you have taken out a black pencil out, then again we can write the probabilities as red and black, but in here it does not affect for red pencils, so there will be 4 red pencils, but the total has been changed as 5. Now there is only 1 remaining black pencil out of 5. Now if you can draw this tree diagram carefully for the questions whatever they have asked, so you can write the answers very easily. without any effort. But the thing is, you have to follow my method. Now they have asked to find the probability that both pencils are red. Imagine this tree diagram as a road for this child. Here there are 4 roads in here. Red to red, you will meet red to red, and red and black, another road, black and red, another road, and the final one, black and black. As you can see, there are 4 roads in here. If this child wants to go to his house by using these 4 roads, in here whatever they have asked for the question, both pencils are red. So now you have to choose the road that the child will pass the boards as red and red. So as you can see, that is the first road. So above those branches you can see 4/6 and 3/5 are the answers. Now you have to multiply those answers. 4/6 when you meet the first red, then 3/5 when you meet the second red. So both pencils are being red means 4/6 into 3/5. So when you simplify, it will be 4/3 means 12 over 30. Then when you simplify that thing again, you can write it as 2/5. That is the answer. As I told you before, that is very simple thing you have to do if you follow the method. If you identify the correct road to go to the house, then it will be very easy for you. For the second question, they ask to find the probability that the 2 pencils are opposite colors. In here, you have to find out how many roads are there and what are those roads. Here, opposite color means when you have to pass red and black. That is 4/6 into 2/5. And there's another road that is black and red. So as you can see, you have to add that value 2/6 into 4/5. That is very simple. Now you have to simplify this fraction. 4/2 means 8. 8/30 plus again 2/4 means 8 over 6 into 5 means 30. Now the denominators are equal, so you can easily add those values as 8 plus 8, 16/30. And you can simplify that answer also. As I told you before, if you follow the method that riding the bicycle using those roads, after you drew the tree diagram correctly, the finding the answers are very easy. So I hope that you will understand this lesson and will meet you back. Thank you.